Today we're going to work on page 29B, 23 through 40 all. This deals again with quadratics. So if you open your book to page 29, the instructions say solve using the square root method and solve by completing the square. So let me remind you of a specific type of polynomial. If I had x squared plus, what's a good one? 8x plus 16. How does that factor? X plus 4 and x plus 4. Okay. This is called a perfect square trinomial. Now, we don't say that a lot, but it's a perfect square because the two factors are the same. So you could say it's a square whose side length is x plus 4 and x plus 4, whose area is this. We also call it a perfect square because I can simplify those factors into one and do x plus 4 squared. Now we use that fact when we complete the square, and we'll talk about that in just a second. But a perfect square trinomial has identical roots. Graphically, what does that mean to have two of the same roots? It bounces off the axis, whether it comes down and bounces off or comes up and bounces off. It only has a single root at that particular spot. So the first set of problems asks you to solve using the square root method. Now most of these are pretty simple. Number 24, you don't have the option except the square root method. Add the 72 over. Oh. Y squared equals 72. And then I square root. So y is equal to what? Don't forget the most important rule. Plus or minus. Way to go. I didn't even have you last year. You get an A. Why is it plus or minus? Anytime you have a variable squared equals a positive number, there are two possible outcomes. So plus or minus the square root of 72. The trouble with 72 is it's not simplified. In fact, there are an infinite number of ways to represent a single number using the square root. Just like there are an infinite number of ways to represent a single number using a fraction. So to make sure everybody has the same answer, we simplify fractions, and you know how to do that. You take out all common factors. We also need to simplify square roots. Now there's a way to do it, and then there's a way to understand it. Do you guys understand what it means to simplify square root? What you're really doing? So you're looking for the perfect squares. What are the perfect squares out there? 1, 4, 9, 16, 25, 36, 49, 64, 108, 100, 121, and so on. Okay? Are any of those perfect squares a factor of 72? 4 is, 9 is, and if 4 and 9 are both perfect squares, then 4 times 9 should also be 1. 36. Does 36 go into 72? Yes. So 36 is the biggest perfect square inside 72. So what I'm going to do is split this into plus or minus the square root of 36 times the square root, what's left? 2. I've identified the largest perfect square that's a factor of 72. But the square root of 36 is really just 6. So this becomes plus or minus 6 root 2. That's the idea behind it. The only trouble is sometimes the numbers get so big, or sometimes you make a mistake when you're trying to identify that perfect square. So the other way to do it is just to factor 72. So 8 and 9, 2 and 2 and 2, and 3 and 3. anytime a factor shows up twice, that creates a perfect square. That's the idea behind that process that we teach you. So here is a perfect square. Which perfect square is it? 4. Here is another perfect square. Which one? 9. So it's 4 times 9, which is 36. And for every group you circle, you get to bring how many out? 1. Why? Because that's the square root of that number. The square root of 2 times 2 is 4. The square root of 3 times 3, or sorry, the square root of 2 times 2 is 2. The square root of 3 times 3, or the square root of 9, is 3. So really what we're doing is the square root of 4 times the square root of 9 times the square root of everything left, which is 2. So 2 times 3 root 2, or 6 root 2. Yes? We'll get to a negative here in a second. Okay? So for some of these easier radicals, the perfect square method works pretty well. So if I said the square root of 50, are there any perfect squares inside 50? 25. And it would be 25 times 2, so that's just 5 root 2. Okay? What about 48? Are there any perfect squares in 48? 4, and it would be 4 times 12, right? Does 12 have any perfect squares? It also has 4. So if 4 works twice, that means 16 should also work, so it would be 16 times 3. So that simplified would be, so this is the square root of 16 times the square root of 3, so 4 root 3. Or if you do it the other way, 6 and 8, 2 and 3, 2, 2, 2. For every pair, you bring one number to the front. So a pair of 2s, a pair of 2s, that's 2 times 2 on the outside with a 3 on the inside. Does that make sense? You finally, now that you're seniors, you now know why that works. So, and don't worry, when you were sophomores, I taught that to you. You just forgot. Either that or you didn't have me. Okay. So, which one, Coy, did you want me to do? Okay, 26. We can do 26. So 26, we know how to solve that using factoring. How would that factor? No, it would be v. It's not v plus 4. It's v plus 4i and v minus 4i. Using the square root method, we subtract v squared equals negative 16, and we square root v equals plus or minus 4i. 16 is a perfect square, so the square root of 16 is 4, and that negative 1 is also a perfect square. It's the perfect square of I. Well, I guess it's not a square. It's I times negative I. All right, number 30. We can still use the square root method this way. Actually, let's do 34. No, never mind. Let's do one that's not negative. Let's do 28. Square root both sides, and I get x minus 1 equals plus or minus 5. Now what? Add 1. We're doing 28. Add 1. Now, it's really common for people to say plus or minus 6. Is that true? No. It is 5 plus 1, which is 6, and then negative 5 plus 1, which is negative 4. Okay? All right, now we can do one of the negatives, like 29. Square root. So 2x plus 3 equals plus or minus 2i. Now what? Subtract 3. So negative 3 plus or minus 2i. And then divide by 2. And you could either leave it that way, who knows what Cynthia Young does. I would leave it like that, or you divide them individually and you say negative 3 halves plus or minus I. But as far as I'm concerned, those are equivalent. I wouldn't mark you wrong for that. I would just leave it like this. Mathematically, that's easier to work with. Most of the time when we use those numbers, you want to leave it in that form. Okay? So, moving on to the next section. Those should be really easy. Hopefully those are really simple for you. The next section seems a little bit harder, but it's not really. So, not very often do quadratics factor as perfect square trinomials where you have, say, x plus 1 and then raise that binomial to the second. But for every quadratic, we can create what we call a perfect square trinomial and use the square root method to solve. Every perfect square trinomial follows the same pattern. So here's one, x squared minus 8x plus 16, x squared plus 2x plus 1, x squared plus 10x plus 25, x squared, let's see, minus or plus, doesn't really matter, minus 14x plus 49. These are all perfect square trinomials, and the perfect squares are as follows: x minus 4 to the second, x plus 1 to the second, x plus 5 to the second, and x minus 7 to the second. And if you notice the pattern, the number inside the factor is exactly half of the middle term. Does everybody see that? Why is that? Well, when you do that distribution, when you multiply using the box, 5x happens twice. So you add a 5x and a 5x and you get 10x. Negative 4x happens twice, and you just add those together. So the middle term will always be double the factor. What else do you notice about those perfect square trinomials? What's the other important factor, important part? What do you notice about these? They're always the factor squared, which turns them all positive. So we can look at a trinomial and immediately determine, is it a perfect square trinomial? So let's take is that a perfect square trinomial? No. Half of the middle term would be 4, negative 4, and negative 4 squared would be 16. So this one does not factor into x minus 4 times x minus 4. But we can turn it into one that does factor and then use that to solve the quadratic. This is called completing the square. So we want it to say x minus 4 squared. Right? We want to turn a non-square, a non-perfect square trinomial into a perfect square trinomial. The trouble is the 12 doesn't match. So I'm just going to move the 12 over to the other side for now. Move that over there. So we get x squared minus 8x, and I don't have anything in that spot, but it equals negative 12. Now, this is correct, but that hasn't been placed yet. What goes in that empty space? 16. How do we know that? It's negative 4 squared. So this would be plus 16. And if I add 16 to one side of the equation, I have to add 16 to the other side. So now this equals 4. I have now created a perfect square trinomial that can be solved using the square root method, just like that first set we had. So instead of factoring it into two different factors, I force it to factor into the same factor twice with a constant on the other side. Then I'll just take the square root and add 4. That's all completing the square is. Take what you have, convert it into a perfect square, and then square root it. So I square root this side, square root that side. X minus 4 equals plus or minus 2. And then we add 4. 2 plus 4 is 6. And negative 2 plus 4 is 2. Are those the factors of the original? Or, the roots of the original? I could have factored it into x minus 6 and x minus 2. And you might say, well, why didn't we do that? Completing the square shows up in lots of places, so it's a skill that you need to know how to do. And completing the square always works. Factoring only works when the numbers are nice. If the numbers are not nice, then completing the square is an option for solving it. Even if the roots are imaginary, completing the square will work. Okay? Take a look at 35. I already have the constant moved to the other side, which is nice. What would the factor be? X plus 1 to the second. So what number am I missing? 1 squared, which is 1. So plus 1 and plus 1. So this equals 4. How do I solve it? Square root both sides and then subtract the 1. 35. X plus 1 squared equals 4. Square root x plus 1 equals plus or minus 2. And then subtract 1. 2 minus 1 is 1. Negative 2 minus 1 is negative 3. Those are the roots. So I have x plus 1 squared. I get rid of the squared by square rooting. Oh, so in order for this to be true, the original quadratic had to be x squared plus 2x plus 1. No, and usually when you move things from one side to the other, you would subtract it, but we already have a balance. And I added 1 pound to one side, and it went out of balance. So to keep it in balance, I had to add the same amount to the other side. There was nothing there to begin with. I had to put this there in order to match my perfect square. And because I added weight to one side, I had to add the same weight to the other side. So that's a good question. Does that make sense to everybody? Yeah. Let's do... No. Let's do number 40. And you'll notice I didn't make you do all of the difficult leading coefficient ones. If there's a leading coefficient, don't complete the square. You can do it, but it's really hard to do. If there's a leading coefficient and it doesn't factor, use the quadratic formula. It's easier. There is a way to complete the square, but there are a bunch of extra rules you need to rely on. And anyway, it's really confusing. So number 40 is kind of tough because that number's not even. So I'm going to move the 12 to the other side. So I'm going to put negative 12 over here and get rid of that. So x minus, what number goes in my factor? And 3.5 is true. It's usually easier to do this in fraction form. It will work in decimal form, but you won't realize it's working until the end. But in fraction form, it usually works out to be a lot nicer. So I'm just going to say 7/2 squared. And it's either going to look really nice and messy at the end, or it's going to look really messy at the beginning and nice at the end. So I prefer fractions. Go ahead and use the decimal if you want. So what number should go there? 49/4. 7/2 times 7/2. And again, 49/4 doesn't seem very nice, but it probably will be here in a minute. So in my calculator, -12 plus 49/4. Oh, oops. So -12 plus 49/4. Math fraction. 1/4. Why is 1/4 a really nice number? It's a perfect square. 1/4 is the perfect square of what number? Wrong way. 1/2. So all of this equals 1/4. Now when I square root it, I get 7 minus, or x minus 7/2 equals, square root of 1 is 1, so plus or minus 1 over square root of 4 is 2, plus or minus 1/2. Now when I add 7/2 to that, what is 1/2 plus 7/2? 8/2, also known as 4. And what is -1/2 plus 7/2? -6/2, also known as -3. Okay? Sorry. All right. Good luck.